Hi everyone, this is Kalyan Kumar here and welcome back to Chemistry Universe. This is video number 8, the chemical properties part 2. And in the previous one, we saw how it behaves as an acid and base and nucleophile. And here we're going to do a very important reaction called oxidation. Remember, we are not going to do oxidation of aromatic amines right now. We will be doing that separately when we do aniline. And that happens to be one of the last parts of this lesson. So what is important about oxidation is there are various ways of oxidizing an amines and you get different kind of products. So you keep that in mind. Secondly, you have primary, secondary, tertiary amines. Even though they are functionally different, in this lesson we are going to do all the three. So that is one part. And not only that, for each of those, we also have a possibility because oxidation involves the breakage of bonds, CC bonds, CH bonds. So it's also important to understand how many H does the alpha carbon have. So sometimes the oxidation products would even depend on that. So keeping all these variations in mind, here is oxidation for you. All right. So if you're going to go slowly towards the oxidation, this is reaction number 9, of course. And first of all, let's deal with primary. And in primary, we are going to first take KMnO4. Remember I said various reagents are possible? So let's do KMnO4. And this is how you need to remember it. First, let's take a primary amine with at least two hydrogens on the alpha carbon. Remember, we have never ever done this. We simply used to take primary amine for granted. But here we need the number of H also because oxidation uses that. So I have a primary amine with at least 2 alpha H. Okay. So with KMnO4, this is how you remember. First, remove both H from carbon and nitrogen. What would you get? Nascent oxygen. What would you get? You'll get an amine, right? And this is from an aldehyde, so it's an aldimine. So now add water. And not add water, I'm saying hydrolysis. And you know that amines will hydrolyze to aldehyde and ammonia. The reverse is how you form these amines, which we have done in aldehydes and ketones. So this is how you do KMnO4 oxidation. Now let's repeat this. If the carbon has only one H, the alpha carbon, so it will give you this. Remove one H, it will be ketamine. And what would the hydrolysis of that get us? Obviously a ketone. So this is how you remember KMnO4 oxidation of primary amines. Now again I take primary amines, but this time I'm going to do the oxidation with a peroxy acid. And that could be a Carose acid. Don't be intimidated by the name. H2SO5. It's basically O bond. Carose, it's called Carose acid. H2O2, again O bond. Peroxy carboxylic acid, O bond. They all do the same thing. Basically, you need OO bond. And this is how you do it. Take the primary amine. This again with 2 alpha H. 2 alpha H comes minimum. And do the oxidation. Now instead of removing the 2H, just remove the H of nitrogen and convert that into an OH. I'm not giving you the mechanisms because they're not required. Now what you do, then the next step of oxidation, this is N-alkyl hydroxylamine. Okay. So let's do an oxidation again. Now this time we have to remove water. And how are we going to remove the water? So we are going to remove water by taking 1 H of nitrogen, 1 H of carbon, and the oxygen, that is the nascent oxygen from these Carose acid. And we are going to remove water and you get this. Remember the OH of N remains, only the H of N goes, the H of carbon goes, and the O that you get from the Carose acid. So this is called aldoxime. Remember? Oxime. Now do further oxidation. In this, I'm going to convert the H of carbon to OH. And that is called hydroxamic acid. So this is the way to remember. First, change one H to OH. Then remove water by taking 1 H from here, 1 H from here, and 1 O from here. You'll get aldoxime. Now change this H to OH. That is how you do it. So what do you think would happen for a primary amine with a secondary carbon? I mean only one H. How far do you think it will go? Using the same logic, what do you think will happen first? Obviously, the H of N will become OH. Next step, water released and you get ketoxime. But remember, there is no more H on carbon for the third O to come and convert that into an OH. So it will stop here. All right. Now, suppose there were no H on the carbon. Well, only the first step will happen as far as this mechanism is concerned. But what can happen is, now obviously water can't be released because the carbon doesn't have an H. But what does happen is that the nitrogen simply loses 2H and you get NO. You know, the OHH and the NHH. That's what oxidation is, removal of hydrogen. And then further oxidation of this will become NO2. So you got to remember this. So this reaction is more for you being able to remember. So pause and just check out these reactions, okay? And then secondary amine, again with KMnO4. Here what happens is that in this oxidation, as I said, the 2 moles being used, both ends will lose 1H and join with each other. So this is called, and those 2H and with this O you get H2O. And this is tetraalkyl hydrazine. And then comes peroxy acid. Well, it's simple. The NH becomes OH and you get this NN-dialkyl hydroxylamine. And tertiary amines, well, they don't react with KMnO4 at all because the tertiary amines, nitrogen don't have any H. But they do react with KOH, with Carose acid. And this is how they do. You get R3N, oxidation, and you get a zwitterion like this. A zwitterion is something which has both plus and minus on different atoms. And even though it's a covalent compound. So this is called an amine oxide, which is also known as a zwitterion. Just remember this stuff. This is only for you to remember, not much of mechanisms here. And that finishes off oxidation. So with that, this is Kalyan Kumar signing off. I hope you understand that you can't get mechanisms all the time and it's not possible to remember all of them. There are some parts of organic chemistry where you simply have to mug up. You have to remember stuff, which is what I always mean by saying that being able to memorize is far more important for an exam than being able to understand. Of course, being able to understand is important. I'm not discounting that. But being able to understand and not being able to remember has no value. At least for an exam. I'm not talking about you being able to master something. I mean, you may not know all the commands, all the things, but you know how to work things out. That's fine. But in an exam, if you cannot remember stuff and you have understood while you were studying, makes no sense. And even if you're able to derive something and do it at that time, you won't be able to do that many questions. So being able to remember is very, very, very important. And I'm not saying that you don't understand, but wherever you can do, wherever you can't, just try and remember this stuff. So that this is Kalyan signing off. Have a great day memorizing this stuff. And thank you for watching.